series of videos that I've prepared for you guys to join the lectures for this course. So the first few sections in this course are very much a review of Math 124. If those of you who have taken that course, this material will be very familiar to you. If not, hopefully this review will be additional help in reminding you a course material that you might have taken, say, a semester or 2 semesters ago. Okay, so let's begin this course, Math 132, and of course, welcome to all of you. Well, the first section is about linear equations. The first thing we want to know about linear equations is that we can model them in a Cartesian coordinate system, also known as the XY plane. Now, I know this set of axes, horizontal and vertical axes, is best known by the name XY plane. But really the most important aspect of this, which is even used in graduate school, is knowing that this axis represents a relationship between independent and a dependent variable. This is the most important aspect of this set of axes. That's the real purpose why we study this set of axes, to model a relationship between an independent variable and a dependent variable. Since I mentioned it, let me quickly write down this equation. You've seen this equation many, many times. Y equals, say, 2x plus 5. In this context, then x is the independent variable, and then y is the dependent variable. And this axis is meant to establish a relationship between these two variables. At least this is a graphical representation between these two variables. This equation is a symbolic representation of the relationship between x and y. We can represent this same relationship using a table of values. So suppose if I draw a quick table here and I say this row represents x values and the bottom row represents the y values, and then let me give a few values, right? -2, -1, 0, 1, 2. And if we plug this values of x into this equation, we get, for -2, we get 1. For -1, we get +3. For 0, we have 5. For +1, we've got 7. And for 2, we've got 9. So here, you have 3 different representations of the same idea, which is the relationship between the independent and dependent variable. So this axis represents a platform, actually. So 0, 5. I should plot a couple of points here. So let's say -2, 1, and 1. So that would be that point here. And let's plot this point, 0, 5, 0, 5, 1, 2, 3, 4, 5. So that would be that point, 0, 5. And then we can connect these with a straight line. I'll use my blue ink to do that. Hopefully I can do a straight job like that. Here's a straight line going through those 2 points. So here now, you have 3 different representations of the same exact idea. The relationship between x and y. The line is the graphical representation of that relationship. This table is a data or tabular representation of that same idea, and this equation is the symbolic representation of that idea. So we have symbolic representation, we have graphical representation, and we have tabular, or let me call this data type representation between the x and y, which are two variables. So talking about the xy axis, we can quickly divide it into 4 sections, right? So this is called the first quadrant. We're going counterclockwise. These labeling are meant to be counterclockwise. So the first quadrant, and then the second quadrant, the third quadrant, and of course the fourth quadrant. So you're familiar with how these axes have their algebraic sign assigned to them. So on this side, the x-axis, we have positive x values. Along the y, we have positive on this side. This is the negative part of the axis, and this is the, again, negative part of the y-axis. Okay. So the other thing that we should know is that whenever you have a line that goes through this axis, let's draw a couple of them here. And another one here. So a line can be drawn with at least 2 points given to us that belong to this line. So you have any two points on this line, you should be able to draw it. But the most, or the easiest, I should say, the easiest points you can use to draw a line are the intercepts. So this one is the x-intercept. For any x-intercept, for any point along the x-axis which happens to be an intersection of a line with that axis, the x value can be determined, but the y value is always 0 for an x-intercept. So for and by the same token, this would be the y-intercept, for which, for any y-intercept, so if this line was a little bit higher or lower and intersected the y-axis at a point, for that point, the y component could be determined, but the x coordinate would always be 0. And I'm just assuming that from the previous classes, you're familiar with the xy component of any point within this xy plane. So the first number being x, the second number being y. So this line, so this is something very important you should remember. For y-intercept, the x value is always 0 and the y can be anything. I just put a question mark there, depending on where this line intersects the axis. And for the x-intercept, the y value is always 0 and the x can be determined. Now this line is sloping uphill from left to right, right? Not the other way around. From left to right, it's sloping uphill, and that's why we say it has a positive slope, because it's an increasing slope going from left to right. So we can draw another line here, and that line would have y and x intercepts, of course, and then this line is sloping downhill from left to right, because it must have a negative slope because the slope is decreasing from left to right. Okay, so we've talked about the line. Now the symbolic representation of this line has three main forms. So these are three main forms of a linear equation. So we have this form, y equals mx plus b, and this is called the slope-intercept form. We have another form, which is y minus y1 equals m times x minus x1, and this is called the point slope form. And of course, we have the general form, which looks like this: ax plus by equals c. And this is the general form of a straight line. So these different forms are applicable and very useful in different situations. For example, this general form is extremely useful when we deal with matrices. So this form used with matrices. And this one is used to finding, given this slope, we can use either of these two equations to find the equation of the entire line. So both of them can be applied for that. And this m, of course, this m is the slope. It's the usually used letter for the concept of slope. Okay, so we've talked about these lines. We will talk about slope in a second, but let's talk about a couple of very important special cases of straight lines. All right, great. I'm sure you've seen this before, so this will be a quick review of that. One is the vertical line. A vertical line, we can easily show it with a line like this. And for this, the slope of a vertical line is always undefined. And we will talk about that in a second, why that is the case. The other special case is you probably guessed it, it's a horizontal line. So this is, well, let me also label this. So this is for a horizontal line. And the slope of a horizontal line is 0. Okay, these are the two special cases. So having talked about these various types of lines, let's talk about their slope, the calculation, and what it means. So the slope formula, that is the steepness of a line, basically. Let's quickly draw a line of some kind, like that. And then let's pick a couple of points along this line. It doesn't matter where they are. Let's pick one point here and another point here. Let's give these general coordinates, these 2 points. So I'm going to call this point has coordinates x1, comma y1. And I'm going to label the coordinates for this point as x2, comma y2, right? Given 2 points along a line, we can quickly and easily calculate the slope for it using this formula. M again is for the slope, y1 minus y2 over x1 minus x2, and that is equal to y2 minus y1 over x2 minus x1. So which one is correct? y1 minus y2 or y2 minus y1? Well, both are correct as long as you remember to keep the order of subtraction the same. So at this point you have the option of whether to do y1 minus y2 or y2 minus y1. But once you pick one order of subtraction between the y components, you got to keep the same order of subtraction for the denominator. So if you say y1 minus y2, then you have to say x1 minus x2. But if you choose to subtract the y components in this order, y2 minus y1, then you're stuck with keeping the order of subtraction the same for the x values. So y2 minus y1 means x2 minus x1. But if you do y1 minus y2, then x1 minus x2. Okay? So we talked about the vertical line and horizontal line. So why is that the vertical line has undefined slope and horizontal line has a slope equal to 0? Well, let's pick a couple of points on this vertical line. Let's pick this one and that one, right? So that one we can label as x1 comma y1 and this one x2 comma y2. Now if we apply the slope formula as we described below, like that, we can write the slope is equal to y2, we can do, or y1 minus y2, y1 makes no difference, over x2 minus x1, right? Notice that I kept the order of subtraction the same, y2 minus y1 over x2 minus x1. Now, looking at these 2 points, y1 and y2 can be anything, right? So let's just keep them as that, general y2 minus y1. But if you take a careful look at the x component of these 2 points, what do they have to be? Can they be different? No. The x component, the x coordinate for these 2 points has to be the same x value. So x2 minus x1, it's going to be 0, right? Because for any vertical line, this is true. The x components or coordinates have to be the same. So if you subtract them, you get 0, and we cannot divide anything by 0, and this will be undefined. Undefined there. So that's why the slope of any vertical line is always undefined. For the horizontal line, why is the slope always equal to 0? Let's find out. So once again, we can pick any 2 points along this line. And this time, let's do y1 minus y2 over x1 minus x2. And I'm going to label these x1 comma y1, x2 comma y2. Now this time, x1 and x2 have to be different, right? It's clear. x1 is going to be here, x2 is going to be here. So we're going to keep those as x1 and x2. But y1 and y2 have to be the same value, right? They have to be the same y value through which this line goes. So that if we subtract the same value from each other, we get 0. This time, 0 divided by any value is equal to 0. Therefore, we have the slope of a horizontal line always equaling to 0. Just apply the slope formula and you see it. Okay, so let's do a couple of examples. We'll start up with easy examples as always. So here's one. We have given the points -1 and 2 and 4, -2. Find the slope. Okay, we want to do that. So clearly, this is our formula, right? y1 minus y2 divided by x1 minus x2. Now, to keep track of things easily, or to minimize chances of making an error, let's label these. So x1, comma, y1, and then x2, comma, y2. So I'm going to look back and forth between these and plug in here. So y1 is 2, then minus y2 is minus 2, divided by x1, which is -1, minus x2. x2 is 4. So what do we have? Let's simplify. Minus 2 is plus 2. We get 4. Minus 1 minus 4 is minus 5. So we have minus 4 over 5. So this is a decreasing slope, right? It's the line must be sloping downhill, going from left to right. Okay, so let's do another example. Whenever I write a problem down, as soon as you see what the problem is, you are welcome to pause. It's a very good idea to pause the video, write down your own solution, then go back to the video and see how I solved the problem. That's always a good idea to do. It builds your skills a lot faster. Okay, suppose then we have an equation. So given the equation y equals minus 3x plus 4, we want to find the x-intercept and the y-intercept, and then graph the equation. We will get to this, we will do this a lot in chapter 4. Here, specifically, it says use the x and y intercepts to graph this equation. But even if the problem doesn't state that, whenever you're asked to graph a line, a straight line, the easiest way is always to use the intercepts. Just remember that, x and y intercepts. Okay, the x-intercept, we recall from a few minutes ago, x-intercept always has the y value equal to 0, and then the x value we should figure out. In this case, we can just plug this 0 for y, substitute for y with 0, because this is an x-intercept, and then calculate x. So let's do that. So we have 0 equals minus 3x plus 4. Let's solve for x. We can move things around. I'm going to move this term to the left. In doing so, it changes the algebraic sign. So it becomes positive, equals 4, and then from that, x equals 4 divided by 3. So the x-intercept is 4/3, 0. That's our x-intercept. For the y-intercept, we know that the x component must be 0, right? Because this point is on the y-axis. So the x has to be 0. And then we're going to find out the value of y. So how is that we substitute in this equation for x with 0 and then solve for y? All right, let's do that. So y equals minus 3 times 0 plus 4. And this will give us y equals 4. So the y-intercept is 0, 4. Okay, so we want the problem asks us to graph this. Let's do that. So you can graph this equation with any 2 points, but it's easiest if you use the intercepts. Okay, I'm going to plot these 2 points. Well, first of all, let me increment this. These are small, easy numbers. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, roughly, right? So 0, 4 would be here. And 4/3, 0, 4/3 is slightly larger than 1. So if this is 1, and that's 4/3 for x, so 4/3 would be right here, roughly. And that's 4/3, 0. And then we can connect those 2 points with a straight line. Like that. And so we have our line. Okay, so when I post these videos, if you have any questions, please post your questions right underneath each video. And also, I will remind you about this again, but you can also join me in a WebEx session, which I will schedule throughout the semester. The benefit of posting your question on the discussion board right underneath each video is that if other people have the same question, they'll get it answered. Okay, so let's see another example. This example wraps up this section, and it's the most important type of example that you can get, because it's problems like this for which we learn about how to find the equation of a line. These kinds of problems are the main reason why we do all this. So okay, given this information, then here's part A. We are asked to find a linear equation describing the on ads or advertisements and sales. Okay, so remember that when I first began talking about the XY coordinate axis just now, we said that the most important reason why we use that is to represent a relationship between independent and dependent variable. So keep that in mind, pause the video, solve this problem, answer it, and find this linear equation on your own, and then come back to the video and see what I've done. Please do that, and I'm hoping that way you build your skills much better and much quicker. Okay, so I'm assuming that you've done that, and now you're back with your solution already in front of you. Great. Okay, so if we read the problem from the beginning, it seems that when the company spends $4,000 on ads, these many boxes are sold. When they spend $6,000 on ads, then $300,000 is sold. So there's definitely a relationship between those quantities. This question then is, which one is the independent variable and which one is the dependent variable? What depends on what, so to speak, right? So it appears that the sales of boxes of cereal depends on, according to this problem, right, depends on how much money is the company is spending on ads. So then I'm going to come here and I'm going to say, instead of, well, let me begin with XY, so you can see the transition. X comma Y is really equivalent to independent comma dependent variable, right? Then, given this information, we can split that into 2 points. So, and in our case, this would be dollars spent on ads. Sorry, this is just on ads. On ads, and this would be sales of the cereal, right? Sales of cereal depends on that, on the ads. So let's use that to set up our points, because we're going to find linear equation and we need at least 2 points for that. All right, so we have when 4,000 was spent, 100,000 boxes were sold. When 6,000 was spent, 300,000 cereal boxes were sold. So now these 2 points become our x1 comma y1 to like that. So now we can use these 2 points to find the slope and then ultimately find the equation. So let's do that. Basically, we're trying to find this equation, right? That's what we want to find. Find this equation. Okay, so to find the slope, we can do y1 minus y2 over x1 minus x2, right? Keeping the order of subtraction the same. So y1 minus y2, that would be 100,000 minus 300,000, according to the way I've labeled these, right? And all of that divided by x1 minus x2, so 4,000 minus 6,000. So this will give us minus 200,000 divided by minus 2,000, and that would be 100. So we have 100 is the slope of this, the equation that we're looking for. So we were able to find m in this equation. Now if we can find the intercept, then we'll be able to write that equation. So how do we find the intercept? We know the slope, okay, and we know the points on that line, on that straight line we're looking for. Well, let's pick one of these pairs of points. It doesn't matter which one. I'm going to pick this one because it's the numbers are smaller. So we have using 4,000 and 100,000, the m equals 100, which we just found, and one of those three types of equations that I mentioned when we began this section. Specifically, I'm talking about the point-slope form of an equation. So this one, y minus y1 equals m times x minus x1. So using a pair of points, or one point, using one point with the coordinates, the slope that we just found, and this equation that we mentioned in the beginning of this section, we can put things together and find the equation of a line. So let's substitute here. In this equation, the y1 is this, and the x1 is this number. And m is clear, right? So let's put it together. We have y minus y1. I'm just plugging into this with all of this information. Y minus 100,000 equals m, which is 100, times x minus x1, which is 4,000. So let's do the algebra, simplify, and get our equation. So y minus 100,000 equals 100x, distribute this, minus 400,000. And then doing the algebra, we have y equals 100x minus 400,000 plus 100,000, right? Why plus? Because we're moving this negative 100,000 to the right. So when we do that, it changes algebraic sign from minus to positive. You can move anything around an equation, it'll change algebraic sign. So ultimately we have 100x minus 400 plus that, 400,000 plus 100,000, we get minus 300,000. So here's the equation that models the relationship between the amount of money spent on ads and the boxes of cereal sold. Again, please make sure that you post your questions right underneath the video on the discussion board where I will be posting all these videos. So this was part A. Let's continue with part B of this problem. In part B, the question is, how much advertisement is needed to sell 350,000 boxes of cereal, right? So let's remember our equation, which was y equals 100x minus 300,000, right? We can rewrite this equation with its description. So y, which was the dependent variable, it was the boxes of cereal sold, right? So let me substitute for y with that. Equals 100. Instead of x, let me write down the description of this variable, which was the independent variable. And that was dollar spent on ads, right? That was x, or the independent variable value, minus 300,000. Well, in this problem, they're telling us how much advertisement. They're asking for this one, right? This is the one that is under question. how much advertisement, that's this piece, is needed to sell 350,000 boxes. Well, so that's, the boxes would be this one, right? So this one, we know it has to be 350,000. So let's solve for that question mark. So we have 350,000 equals 100 times X, because it's question mark, right? Dollars spent on ads, minus 300,000. So once again, let's combine the constants together. Bring this negative 300,000 to the left. In that process, instead of negative, it becomes positive. Plus 300,000 equals 100x. So we have 650,000 equals 100x. And then x will be 650,000 divided by 100. And of course, that is equal to $6,500. So if the company wants to spend or wants to sell 350,000 boxes of the cereal, they have to spend $6,500 on ads, according to this relationship. Before we wrap up this section, I want to mention something about the algebra of solving these equations. When we all take middle school classes, at that level, the way they show us how to solve this is add something to both sides, subtract something to both sides, because they want to show us what we're doing. They want to make sure that we understand the logic behind solving an equation, because equation is a balance between two sides, and if you're doing one thing to one side, you got to do the same thing to the other side, multiplying it both sides by the same number, dividing it by the same number, if you're interested in preserving that balance or equation. But as you enter college, as you're moving up, that way of thinking about these kinds of solutions becomes highly inefficient. So the more efficient way is of solving an equation is, just remember, when you're solving for a variable, your ultimate objective is to isolate that variable by itself, just like what I've done here, by itself. In doing that, you can move things around as long as you remember to change the algebraic sign. So you don't have to say here, add 300,000 to both sides. That's correct, but it's inefficient. It wastes your time. Just remember, you want a constant, you want to add up the constants together, so you need to move this to this side. And just in doing that, just change the algebraic sign to positive. And in that way, you'll save time when you go over this during exams. Well, we have wrapped up this section 1.1, and we will begin section 1.2 next time.